Hello everyone, and welcome to the recursion section of this course. So in this lecture, what we're going to do is quickly go over what you can expect in this entire section, and then we'll go over the introduction to recursion lecture. Okay, so what's coming up in this section of the course? First, we have an overview of recursion, what it is and why we use it. Then we'll have some basic recursion examples that we'll walk through. After that, we'll get an introduction to memoization and dynamic programming and how it relates to recursion in general. And then we'll end it with 4 real interview practice questions for you to check your solutions against. Okay, so let's go ahead and get started with this lecture where we go over the basics of recursion through an introduction. So, what is recursion? There's 2 main instances of recursion. The first is when recursion is used as a technique in which a function makes one or more calls to itself. This is the main instance we're going to be focusing on throughout this entire section, since it's the one that comes up most in interview-style questions. It's important to note that a second instance of recursion is when a data structure itself uses smaller instances of the exact same type of data structure when it represents itself. We'll focus on this later on in other sections of this course. But for now, we'll focus on when a function makes one or more calls to itself. Okay, so why use recursion in general? Recursion provides a powerful alternative for performing repetitive tasks in which either a for loop or a while loop isn't really ideal. It should be noted that most modern programming languages support recursion, and recursion serves as a great tool for building out particular data structures. So, let's go ahead and start this with an introduction by example using a factorial function. So the factorial function is denoted with an exclamation point, and hopefully you're already familiar with it. It's defined as the product of integers from 1 to some number n. So n factorial, or n exclamation mark, is equal to n times 1 times n times n minus 1 times n minus 2 times n minus 3, continued on until you reach 3 times 2 times 1, etc. Now, what's important to note here is if n equals 0, then n factorial is equal to 1. That's important to note because we're going to be using this as our base case later on. So, let's look at a quick example. 4 factorial is equal to 4 times 3 times 2 times 1 equals 24. So, how can we state this in a recursive manner? And this is where the concept of that base case is really going to come into play. So, we can see that 4 factorial is equal to 4 times, and we can group everything else together, 3 times 2 times 1. So we realize that this is actually equal to 4 factorial is equal to 4 times 3 factorial, which is equal to 24. So you note here we can keep making recursive calls to this factorial function. And to write that formally, we can say n factorial is equal to n times n minus 1 factorial. Okay, so the base case is the key to understanding this. If n equals 0, then n factorial equals 1. So this means that the base case occurs when n equals 0. The recursive cases are defined in the previous equation, right here. So we have the recursive cases, and then we have our base case. And this will be clear when we actually code this out live in a Jupyter notebook. So, a quick reminder, whenever you're trying to develop a recursive solution, it's very important to think about the base case, as your solution will need to return to the base case once all the recursive cases have been worked through. So eventually, after going through every single recursion case, you'll come up to the base case. Okay, so let's actually code this out so it becomes a little more clear what a base case is and what the recursive cases are, and how we can build recursive functions off of that. Okay, so what we're going to do is jump now to the Jupyter Notebook and code out the factorial example. Alright everyone, now we're at the Jupyter Notebooks. As always, you can check out more information on what we just went over in the Introduction to Recursion notebook here, and it goes over everything we just went over in the slides. So let's go ahead and get started with some live code, which is also in this notebook and we'll be working out through this sample notebook. Okay, so recursion, and let's go ahead and tackle this factorial function. Remember, the factorial function states that n factorial, if we write this in a recursive manner, is equal to n times n minus 1 factorial. And our base case is if n is equal to 0, then n factorial is equal to 1. So you can imagine eventually this term here, n minus 1 or n minus 2, n minus 3, etc., will eventually become n equals 0, and we'll have this base case. Okay, so let's start out writing our function. We'll call it fact, and it will accept the number n, and it's going to return the factorial of n. So we want to start off with the base case. So the base case happens, like we said, if n is equal to 0, I will return 1. Okay, so let's go ahead and mark that through a comment as our base case. And then we're going to have an else statement. So if the base case isn't met, what we want to do is return that n times, and this is where the recursive call comes into play. We call the function itself and call it on n minus 1. And that's our function. That's really all there is to it. This is a pretty basic example of recursion. And we can see that factorial of 5 is equal to 120. So what's important to note is we had an if statement to check if a base case occurred here. Without this function, it wouldn't have successfully completed running. And there's a figure in the Jupyter notebook for you to go ahead and check out so we can see what's actually happening when we run this function. Sometimes recursion is a little hard to visualize, so hopefully this helps you out here. So we input our function and we input 5 into the function. So it says, all right, 5 factorial. So we pop back here, we're inputting 5 for 5 factorial. It'll check if it's the base case, which it's not, so or else, and if it's not that, then it's going to return n times factorial of n minus 1. So it's returning 5 times 4 factorial. Now remember this is recursive, so now it's calling 4 factorial, so that becomes 4 times 3 factorial, etc. 3 times 2 factorial, 2 times 1 factorial, and then that goes to 1, returns 1, 2 times 1 equals 2, returns 2, 3 times 2 equals 6, returns 6, returns 24, returns 120. And that's how we get our final value. So make sure you take your time. You can follow this chart from the top to the bottom and then back up to reach the base case. So recursion is a really powerful tool, and it can be a bit of a tricky concept to implement. So what we're going to do is, in case you had a little trouble understanding what just happened here, in the next couple lectures, we're going to go over a few more example problems for recursion. Then afterwards, hopefully you'll be fully prepared to face some real interview questions involving recursion. What I want you to do is, if this was a little bit troublesome for you or you're still not completely understanding it, see if you can add some print statements to print out all the steps or print out some sort of statement for yourself so you can see what's actually happening as the function is being run. Okay, I'll see you at the next lecture.